like, share, and subscribe to my YouTube channel. Thank you for your support. Hello guys, welcome back to this YouTube channel. This is Jonathan Goldfish. So for this video today, we are going to enter the last two chapters of the Among the Pure Mathematics 1, which is the Chapter 7, Differentiation. So finally we are touching the calculus topics among the Pure Maths 1. Alright? Well, in the previous video, we are discussing about the Further Mathematics Chapter 1, FP1, right? But the reason of coming back the Pure Maths 1 is because of Chapter 2 involves the differentiation, which is the rational function graph, okay? Because it includes the stationary point as the one of procedure of the graph. But let's dive into the basics of the differentiations now. Okay, differentiation is the one of the branch of calculus. Okay, what is calculus? Calculus is a branch of mathematics which calculates and get the accurate values of the quantities which is unmeasurable or uncountable, which involves continuous the most. Like, okay, so for the calculus, it involves the limits, differentiation, which is the dy dx. It's very common. And now, finally, the integration. This one you will learn in the next video, which is the last chapter among the Pure Maths 1, integration. Well, the next video isn't the chapter 8 integration because this chapter is considered a long chapter and even longer for integration, right? So differentiation can be also known as the derivative. Okay, it's actually the rate of change of the function with respect to its domain. In other words, it is the gradient of the tangent function. So how does this work? This can be explained by using the Newton's first principle. All right, which has a wider symbol of dy dx. So d, tell me what is d? D refers to small change, okay, or the f prime x. Well, instead of pronouncing this f prime x, you can say the gradient function of the fx, okay? As long you have to know its meaning, right? So according to the Newton's first principle that you have learned from your secondary school, dy dx is equal to the limits of the change of the y divided by small change of the x as the small change of the x is approaching 0. Well, this, let me visualize over here. Okay? I think it's better for us to use the decimals, okay, for the further visualizations for your understandings. Take any 2 points which lies on the curve of fx. So this is the gradient of chord, but this is not the gradient of the tangent that we want to find. Okay, given that there is a small change, which is the difference of the x coordinate, as you see over here, they can be constructed a right angular triangles, okay, as I have drawn over here. So as we narrow the small change of the x, okay, as the small change of the x is approaching 0. However, it is impossible to divide by 0 because it gets undefined. So instead, we can use the first principle because somehow the small change of y can change and simplify the small change of the x. All right, take the gradient of a chord. Let the 2 points go closer from each other. Okay. So as we know that what is gradient that you have learned from chapter 3, it is the y2 minus y1 divided by x2 minus x1. Use the fact of it over here. Okay, which each has the small change of x as well as the small change of y, where small change of y, small change of y is the fx, where its object is replaced by x plus change of x. Okay? Use this expression divided by small change of x. This is your gradient. But we haven't to take limits because we want to get rid away the small change of x. Okay? So since it is indeterminable, we have to take limits to get the accurate value of the derivative. So yeah, this is the brief explanation of using the Newton's first principle to define the derivative or differentiation. Okay? So this is just for your understanding. In fact, it won't come out in the external examinations. So now let's proceed to the important parts. This is our actual topics in A levels, which is or in AS level, rules of differentiation. Okay, this is very essential for each of these functions. So in your AS syllabus, you will learn about the differentiations and even integrations in algebra only. In other words, you will learn the derivatives of the polynomial functions only. Okay, so for the first, constant function. Okay, what is constant function? It means there is a function which is equal to a value without the x. It is independent from x, right? Which means that it does not have the x degree. So no matter how much of this constant, the derivative you get is equal to 0. Okay? Why? The reason is on the second point. So the general first derivative for the polynomial functions, given the function of fx is equal to x power n, okay, to get its dy dx, it is multiply by its original power, okay, and then its original power minus 1. Okay, I repeat again. The dy dx of the xn, a polynomial function given, alright, where n subsets to all real numbers, is n times x to the power of n minus 1. Okay? So since a constant can be written as k x to the power of 0, because anything powered to 0 to get 1. So to differentiate this, it is k times 0, and no matter how much it is negative 1, you will still get 0. Right? So this is how the polynomial functions, the derivative of the polynomial functions defines for the constant function. Okay? So I have I have the 3 stars over here. Okay? Please remember over here, because some might appear in the NF19, but some are not. Some is not, sorry. Okay? And I sorry to inform you that the k is also subsets to the Orion numbers. Okay. Let's see the third point. A coefficient beside the function. Okay? Where the given function has the xn but with the beside of kn, of course, this is not related. Okay? So no matter how you differentiate lah, the constant beside the functions must be taken out. Okay? Then you differentiate the function inside. Right? Where k and n subset to real numbers. Or we can say that the differentiation, the dy dx of the given function y is equal to kx to the power of n is k take out times the n times the x to the power of n minus 1. Remember about this. Right. Now the next. Now for the arithmetic derivative or the sum or difference of the derivative. So if the given function hx is equal to fx plus or minus gx, okay, the the derivative of the hx is the derivative of the fx plus or minus the derivative of the gx, okay, or the y is equal to the sum of the two functions. After you differentiate it, you will get the differentiation of the first function plus or minus the differentiation of the second function. Okay, take note about it, right? So I think you have to memorize about, I mean understand about these rules of the differentiation, because these three rules I stated over here do not exist in your MF19 except for the polynomial functions and the chain rule. Now let's enter the chain rule. Okay, so for the chain rule, which means that the given function y is equal to f of the gx, or a gx is a functions, okay, lies on the domain of the fx. No, this is not function. Okay, maybe I explain in another way. It is, let's say fx is a trigo, fx is a polynomial functions, let's say x squared lah. What about gx? Okay, this is fx. What about gx? Let's say gx is 2x plus 3. So what it means is the fx is the outside function maps into the entire gx. So this is how does the function form. Okay, and this, I know this is for your understanding. This might confuse you, but try to get it. So your polynomial, your functions, for example, you will get the 2x plus 3 and then square, don't forget, inside the bracket. Something like this. So this will involve chain rule. Okay, fortunately it exists in your MF19. So how to differentiate these inside functions? How to differentiate this kind of functions? Okay, for g and f are both differentiable. Okay, where g is differentiable function at point of the x, and f is differentiable at the point of the gx, which means that fg(x) is also differentiable, where fg is the composite function. Okay, sorry to mention that. In other words, how to differentiate the composite functions. So first, we can use the u substitution approach to get its derivative. Let the u is equal to gx. Okay, after differentiate this function, you will get du dx is equal to g prime x. Okay, some students ask me why it's u instead of y. Okay, because the given variable of it is between u and x. So that's why there's a u and an x, which means that there's a axis of the small change of u respect to the small change of x. Meanwhile, after you have substituted the gx as u, differentiate this respect to the u, which comes out as dy du is equal to the f prime u. But I want dy dx, not du dx or no dy du. So we have to use the chain rule, which is the dy dx is equal to dy du times the du dx. Because this aims to get rid away the u. We want the dy dx has the terms of the x. So you have to dy du substitute as g prime x that you have differentiated and the f prime of the gx, ygx because you substitute back the u already. Okay, so here is the best prompt for you in the AX level. You will only learn the derivative of the algebra. Okay, so yeah. Okay, when you are dealing with the complicated differentiation, when you deal with the composite functions, use the chain rule approach. Okay, and this gives you the standard idea. Right. So far, what we can summarize over here, the rules of differentiations are just for the polynomial functions. Okay? So if you want to master these rules, please do practice so. Right? So yeah, we have ended this subtopic. Let's enter the next subtopic. Alright guys, my apologies. Okay, the orders of derivative is still considered as the first subtopic. Alright. The actual next subtopic is the gradient of the tangents and the normal of any curve. This one we will discuss later. So, about the orders of derivative, it depends on how many times you have differentiated the given function. So the given function, let's say y is equal to fx, right? If you differentiate once, this is the first derivative. This is so-called first order. Okay? If you differentiate again, differentiate once, and differentiate again, differentiate twice of it, this is so-called second derivative. Or it's this function, it is second order. And next is the third order. Okay? Fundamentally, following its pattern, it is the how much you differentiate means it is nth order, right? So this is the recurrence notation. So hence for the f, the bracket of n refers to how many times you differentiated is equal to dny divided by dx to the power to the dx to the power of n. It means that how many you differentiate with respect to x. Okay? I mean how much you differentiate the y respect to how many times you differentiate respect to x. Okay? But in AS syllabus, you will only learn at most second order of derivative, which denotes the nature of the turning points. Okay? For this, we will explain it later. I mean, we will discuss later. So yeah. Until now, that's the end of the first subtopic. Let's go to the second topic. I mean second subtopic, sorry. Alright guys, let's move on to the second subtopic, which is the gradient of the tangents and the normal for any curve. Okay. So as we have learned that the gradient of tangents is actually the dy dx that we have approximated by using the limits. So I'm not going to repeat the facts again over here. Alright, so the gradient of tangents only touches one point to the curve. Okay, you differentiate the curve, it actually represents the gradient of tangent, the tangent function. Just that if you want to get the real gradient, we have to substitute these x coordinate values inside the gradient function. Okay? So now for the introduction of the normal lines. Okay, normal is the line which is perpendicular to the gradient of the tangent. So this fact is very fair enough because you must recall what you have learned from your chapter 3, which is the coordinate geometry. Okay, so for the tangent and normals are perpendicular to each other, their product of gradients is -1. For this, we can use the proof of the double angle formula for the tangent because tangent theta is actually the gradient and mathematically a gradient. So to get the gradient of the tangents, differentiate the curve functions, and then you substitute the x is equals to sp, where xp is the coordinate of the contact point, right? But explaining at here, in here, is insufficient for you to understand. Instead, we can proceed to the procedure of to obtain the equations of the both tangent and the normal in any curve. So first step, differentiate the dy dx, okay, or the equation of the curve, get its f prime x. Next, equate the derivative to the gradient of tangent by following the Newton's first principle, but Newton's first principle is for your understanding. You just have to know the fact of dy dx equals to the mt, gradient of tangent. Next, substitute of the x coordinate of the point of contact inside the derivative to get its value. So by right, the gradient of tangent must be real number. Okay? And if you want to get the y coordinates of the contact point, of course you need to sub its x coordinate inside the original equation of the curve. Okay? It's very simple for you. And I want to obtain the why I need to use the both x and y coordinates, because we want to form an equations for the both gradient of the tangents, both tangent and the normal. Okay, so this is the procedure of finding the gradient of tangent by using the gradient proportions. Y minus yp, change of y, x minus xp, change of x, is equal to mt that you have obtained in real values to get the equation of the tangents. Okay, but for the normal line, you have to convert the gradient of tangents into the normal functions by using the m1 times m2 is equal to -1. But I have summarized the gradient of normal, the formula of getting the gradient of normal in terms of the gradient of tangent. It is the -1 divided by gradient of tangent. And next, use the same way. It is, oh, sorry guys, there's a corrections, my mistake. So this one should disappear, alright? So this is your actual gradient formula to get the equation of normal, y minus yp, x minus xp. Because the point in context is an intersection points for the normal line, tangent line, and the curve simultaneously, right? So this is how you get the equation of normals, alright? I'm not encouraging you to memorize these procedures, because to master this, you have to do partial questions, alright? Or you can practice from basic and then to the advanced, just like that, right? So that's all for this subtopic. Let's move on to the increasing and decreasing functions and the stationary point. Wow, what a fast walkthrough for this chapter. So now we are entering the next subtopic, which is the increasing and decreasing functions and the stationary points. Okay, which it relates the dy dx between the dy dx and 0 for each particular condition. So what's the theorem for the increasing and decreasing functions? Check it below. I have started over here for you to understand, but mainly you have to do practice. No matter what kinds of practice, okay? Try to get mastered about the theorems that you have learned over here. Okay, dy dx, as we have known that dy dx is the derivative or the gradient of the function. So now we can use the fact of these definitions, okay, to determine whether the point of contact is whether the original functions is an increasing functions or decreasing functions, and even at the certain x coordinate, it's a stationary points. So to get the stationary points, its gradient of the tangent must be in horizontal lines. Okay, in the other words, the gradient of horizontal line is equal to 0. Right? So here is it. Okay, before we explain about explain the theorem by using the graph, I want to clarify that x1 to x2 is any random intervals as long the fx is a continuous function. So for the fx, f prime x is greater than 0 from x1 to x2 means that means y is y equals to fx is an increasing functions for this certain interval. And what about decreasing functions? Okay, its gradient is going down, or the gradient is negative, which means that its slope is a negative slope. I mean the slope of the tangent, right? From x1 to x2. Okay? And what about f prime x is equal to 0? It means that there, uh, there is a stationary point. Alright? So which means that the y equals to fx is constant for all values of x. But it's actually no. Right? Because let's say this has a gradient of this has the dy dx of 0, which means that this is a stationary point. But the actual theorem is its tangent is a horizontal line, so that's why its gradient of tangent is 0. Right? So here's the conclusion. First, the gradient is greater than 0. F is increasing from 0 to x1. Okay? Gradient is negative from x1 to x2, which means that the f is decreasing from x1 to x2. And what about the gradient of tangent is equal to 0 and x equals to 1, which means that this point is a maximum point or the turning points. Turning points or stationary points. Okay? Which means that where f is constant for the x value. I mean, when you walk through each coordinates in its tangent, the y value is always the same. So now let's dive into the theorem of the stationary points. Okay, stationary points, which means that there is a horizontal line with where the point of contact is an intersection point between the horizontal tangent and the curve. Alright, simultaneously. In the other words, the dy dx is equal to 0. Or the f prime x is equal to 0. And as I mentioned before, there is a nature of the stationary points by looking at its second derivative, which is the gradient of the gradient function. See how does it interpret whether the f is increasing or decreasing? I mean, f is increasing or decreasing for the gradient. Sorry, it's actually the gradient function is increasing or decreasing. No, actually it is. The nature of stationary points is classified as maximum, minimum, and even the point of inflection. Alright? This is how you visualize the nature of stationary points by using the diagram illustration. So taking the points over here, so by using the signs of the dy dx, you know that this is an increasing functions. Meanwhile, this is decreasing functions for the intervals that I have highlighted over here. So which means that it is from increasing to the decreasing, which means that this point is a maximum point where its second derivative is negative. And what about the minimum? Minimum means that um, from here to here is a decreasing functions. After it passes through the stationary point, this f is at increasing functions for this interval. Okay? So generally, this point is a minimum point with its second derivative is positive. We call minimum. Alright? So if there is a maximum point, the second derivative negative. For minimum point, second derivative is positive. Okay? So these are the best summarized for you. Unless for your second derivative, you still get 0, it is the point of inflections, which means that the pattern of the fx doesn't change. For any x, for x coordinate is go through. For the each x coordinate has gone through, right? Is went through, sorry. Okay, why I put the plus or minus over here, which means that where this interval is increasing, another side is increasing. Otherwise, when the left is negative, is decreasing, the right side must be negative as well. Okay? Or the pattern of the increment doesn't change, which means that there is a point of inflections. At the same time, it is also a stationary point, right? So this is very essential because external examination includes about this sometimes. Okay, don't think about it. Only comes out in the Indian variant papers, but the variant, the complementary does too, right? Okay, let's jump into the procedure of the finding stationary points with its nature. First, take the first derivative from the original equations, okay, or the equation of curve. Next, I want to find its stationary point. Equate the derivative to 0. Then you solve for the x coordinates. Okay? So, which means that xp is the x coordinates at its point where the point has the dy dx is equal to 0, which means that is the stationary point. But we can't get to know whether it is maximum or the minimum point. It's okay. We can take the second derivative to find its nature. Alright? Then you substitute the x is equal to xp to determine its nature of the stationary points. But if the question asks you to find the coordinates of stationary point, of course you need to get the y coordinates by substituting the x coordinate that you have found from dy dx is equal to 0 inside the original equation. Okay? And then you may restate the coordinates of the stationary points as well as the nature of as well as its nature, if any. Okay? So yeah, this procedures of finding stationary points is very general in the in your external A-level examinations. So this summary is for you. But before we end this video, okay, let's go to the tackling of the problem solving questions. Whether the certain variable or quantity is maximum or minimum. I mean, the nature of the quantity or the variable. So first, draw a diagram from the given questions, if any. Okay, or else this step is optional because all informations are given to you. Okay, next, choose letters to represent the unknown quantities instead of between y and x. Alright, so these are the examples. I'm not going to explain it one by one. Third, express the quantity to be maximized or minimized, but in terms of just one variable, like y in terms of x, v in terms of r, v in terms of h, something like that, right? So I want to take the a in terms of r, so get rid away the other unrelated variables. Okay, using your previous mathematical knowledge. Then differentiate the quantity respect to the variables. I want to find the stationary values of the quantity. So you have to take the derivative equal to 0 to get the variables. Then substitute the variables into the equation of the original quantity that you have derived, okay, to obtain its maximum or minimum quantities. If any, if you want to determine the nature of the quantities, take the second derivative and substitute the value inside. Alright, so yeah, that's all for the procedures of tackling the maximum or minimum problems solving questions. Okay, sometimes the problem solving questions for the differentiations is very common for the maximum and minimums. So yeah. Okay, I may stop the video here because it takes a longer time to finish recording about this chapter because we have to discuss the exercises for chapter 7. Okay? However, there's a trailer of in the next video for you. So in the next video, we are going to enter the last subtopic among this chapter, which is the rate change. Well, it is closely related to the chain rule. Alright? Well, this subtopic is considered as short topics. And next, here are the exercises for chapter 7. Okay? After finish viewing my videos, alright, tell me what do you learn in the first 3 subtopics that we have discussed over here. Okay? You may try out each of the exercises. Okay? Exercise for chapter 7 consists of the 41 questions. Okay? If you know, try it out some. If you not able to do, you may reach out to me without hesitations. So yeah, that's the end of this video of the part 1 differentiations. Alright, so thanks for watching. Make sure to click on the subscribe buttons if you like it, if you find this video useful, as well as the bell for the further updates. Okay, I will see you in the next video. Bye bye.
To be continued. Chapter 7, Differentiation Part 2.
Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.